Hello everyone, welcome back. Let's talk about another medium problem on LeetCode today. Number of subarrays with odd sum, LeetCode 1524. If you are new to the channel, consider subscribing. I try to make daily videos on the problems related to data structures and algorithm, including detailed explanations, optimized solutions, and step-by-step walkthroughs to help you improve your coding skills. Now to the problem. In this problem, we are given an array of integers r and we should return the number of subarrays with an odd sum. Since the answer can be very large, we can return it modulo 10 to the power of 9 plus 7. Then in example 1, for the given array 135, we can form the subarrays starting with element 1 as 1, 1, 3, 1, 3, 5, and their sum will be 1, 4, 9. Similarly, we can form the subarrays starting with element 3 as 3, 3, 5 with the sums 3 and 8. And finally, for element 5, we can form only one subarray starting with element 5, which is 5 itself, with sum equal to 5. So out of all of these subarray sums, we have 4 subarray sums which are odd. Hence, we will return 4 as our answer. Similarly, in example 2, all the elements given to us are even. So no matter how we form the subarrays, we will always get subarrays with the even sum. Hence, we will return 0 as our answer. Now in terms of solution, the naive approach can be what we did in the example walkthrough. We would generate all possible subarrays using nested loops and count how many of them have the odd sum. However, the time complexity of this approach is O of n cube, where n is number of elements in the array, because generating all the subarrays takes O of n square time because of the nested loop, and then for each subarray, summing up the elements requires O of n time, resulting in overall time complexity of O of n cube, which is super inefficient. Another approach can be, since we want the count of subarrays with odd sum, dynamic programming can also help. In this method, at each index, we will count the number of subarrays that have an odd sum, effectively breaking down the problem into smaller subproblems. By solving these subproblems in a bottom-up manner, we would eventually compute the solution for the last index and return our answer. However, today we won't be solving this problem using dynamic programming. As the problem revolves around sums, simpler and more efficient method like prefix-sum can help us achieve the same result. Now, in the naive solution, we were computing the sum of every possible subarray from the scratch, which was inefficient. So, can we do some kind of pre-processing to avoid recalculating the sums repeatedly? And the answer is yes, by using the prefix-sum. Prefix-sum is an array such that each element at index I represent the cumulative sum of the array from the beginning to the ith position. For example, for the given array 2, 3, 4, 7, the prefix-sum at index 0 is 2. Then the prefix-sum at index 1 is 2 plus 3, that is 5. Prefix-sum at index 2 is 2 plus 3 plus 4, that is 9, and so on. Prefix-sum efficiently calculates the subarray sum between the indices I and j in constant time by subtracting the prefix sums at two specific indices. For example, we can calculate the sum between the indices 1 and 3 by subtracting prefix sum at index 0 from prefix sum at index 3, that is by subtracting 2 from 16, which will give us output as 14 in just one operation. And we have seen similar problems in the past. Please check out the I button for that. Now let's see how we can apply prefix sum in our problem. For the given array, the prefix sum will be 1, 3, 6, 10, 15. Now let's focus on prefix sum at index 3, where cumulative sum is equal to 10. In the naive approach, we were creating the subarrays starting from every possible index. But now with the prefix sum, we can efficiently answer the range queries. So instead of focusing on building subarrays, we can ask more specific questions like how many subarrays with an odd sum can be formed that end at a given index. For example, let's try to answer this for index 3. How many subarrays ending at index 3 have an odd sum? If we look at the subarray sums ending at index 3, including the element 4, will be 10 minus 6, that is 4, which is even, or we have 10 minus 3, that is 7, which is odd, or we have 10 minus 1, that is 9, which is also odd. Or we can have this whole subarray which has sum equal to 10, which is again even. So we can see that there are two prefix sums ending at index 3 which are odd. So then another approach can be that for each prefix sum, we can calculate the number of odd subarray sums by iterating through all previous prefix sums. For example, for prefix sum at index 3, we went through prefix sums at index 0, 1 and 2 and check the difference and see if the sum is odd. If it is, we will increment our answer, which we will return once we are done with both the loops. And because this requires nested loop, the time complexity will be O of n square, as the outer loop iterates over each prefix sum and the inner loop iterates over all the previous prefix sums to count the odd differences. So now the time complexity is better than naive approach, but it is still not very efficient. So to improve the time complexity further, let's look at this mathematical point. When we subtract an odd number from the even number, we get the odd number back. Or when we subtract the even number from the odd number, we get the odd number back. So our current prefix sum is even. So if the current prefix sum is even, subtracting an odd prefix sum gives an odd subarray sum. Similarly, if the current prefix sum is odd, subtracting an even prefix sum gives an odd subarray sum. So this can also be stated as we will always get an odd sum if the prefix sum at jth index and prefix sum at I minus 1th index have opposite parity. It is similar to XOR operation in this logic, but let's keep our solution straightforward for our discussion. So if we use this information carefully, we don't require the nested loops. For example, prefix sum at index 3 is 10, which is even, and looking at the prefix array visually, we see that there are two odd prefix sums which are 1 and 3 at indices 0 and 1. So if we calculate the subarray sums between these two indices and index 3, we will get two subarray sums which are odd. Hence, along with calculating the prefix sum as we iterate over the array, we can also keep track of number of odd prefix sums seen so far. Let's use the variable odd for it. Now, if the current prefix sum is even, say at index 3, then the number of odd subarray sums we can form ending at this index will be equal to number of odd prefix subarray sums we have seen in the past. Similarly, we should track number of even prefix sums we have seen so far. Now, if the current prefix sum is odd, we can add the count of even prefix sums for the same reason. Additionally, there is no need to store full prefix sum array because we can simply maintain a running cumulative sum in O1 space. Now let's see this in action. Initially, number of odd prefix sums will be equal to 0. Number of even prefix sums will be equal to 1 because our current prefix sum is equal to 0 and 0 is an even number. So number of even prefix sums will be equal to 1. Now we start iteration on the array and first number we see is 1. So our cumulative sum now becomes 0 plus 1 equal to 1. And now since this is an odd prefix sum, how many odd subarray sums we can form will be determined by number of even prefix sums we have seen so far, which is equal to 1. So we set our answer at this point equal to 1. And since it is an odd prefix sum, we increment the number of odd prefix sums by 1. Then the next number we see is 2 and calculate the prefix sum, which is 1 plus 2 equal to 3, which is again odd. And how many odd subarray sums we can form ending at this index? Again, it will be equal to number of even prefix sums we have seen so far, which is 1 in this case. So we increment our answer by 1. And also, since the current prefix sum is odd, we will increment the number of odd prefix sums to 2. Then the next number we see is 3. We add it to our cumulative sum and now our cumulative sum becomes 6, which is even. And now number of subarray sums ending at index 2 we can form will be determined by number of odd prefix sums we have seen so far, which is 2. So we add 2 to our answer. And now since this prefix sum was even, we increment the even count to 2. Then the next number we see is 4. Our cumulative sum becomes 10, which is even. And number of odd prefix sums we have seen in the past is equal to 2. So we add it to our answer and increment the even prefix count. Then the last number we see is 5. So our cumulative sum becomes 15. So we increment our answer by number of even prefix sums we have seen so far, which will be equal to 3, and increment the odd prefix count to 3. And now we are done with all the elements. So our answer will be equal to sum of all these elements, which is equal to 9. So now the time complexity of this approach is O of n, because we are going through each element in the array only once. And in terms of space complexity, it is O of 1, because we are using few variables here and there. Now let's jump into the code part. First, let's initialize few variables. Let's initialize the counter for odd prefix sum as 0 and even prefix sum as 1, because the prefix sum before processing any element is 0, which is even. Let's also initialize our answer to 0 to store the count of subarrays with odd sum. Let's initialize current sum to track cumulative sum of arrays as we iterate through it. And let's also initialize the modulo variable to keep the result within the bounds for large numbers. Now we will go through each number in the array and add it to the current sum. And if the current sum is even, then we will add number of even prefix sums we have seen to the answer and increment the even counter. Otherwise, if the current sum is odd, we will add count of odd prefix sums to the answer and increment the odd count by 1. And in any case, we will apply the modulo operator to keep the answer within the range. And once we are done with all the numbers, we will return our answer. Now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.